Essential Understanding 9 tells us that there are several ways of reasoning, all grounded in sense-making, and that these can be generalized into algorithms for solving proportion problems. Because there are several ways of reasoning, the ways of reasoning that a particular student may have for understanding the relationships in a proportion can help that student find ways to solve proportion problems that will apply to all proportions. So I chose to illustrate this with problem 6, which is a milkshake problem. The recipe for this milkshake is made by mixing 2 parts of milk to 7 parts of ice cream. And a question that we have is how much milk and how much ice cream are needed to make 3 cups of milkshake. So first I noticed that we're looking for a total amount of milkshake, so I'm going to determine what the total number of parts are in this recipe, and there are a total of 9 parts because there are 2 parts summed with 7 parts, and in total that's 9 parts of the same size. So at first we're going to focus on the milk in this recipe, and as you see I've set up a proportion with a missing value here. 9 parts of milk are to 9 parts of shake, as some amount of cups of milk is related to 3 cups of shake, which is the total amount of milkshake that we want. So since our parts are of equal size, I'm going to say that 2 cups of milk are related to 9 cups of shake to make things easy on myself. So now I just have to determine that if 2 cups of milk are related to 9 cups of shake in this recipe, how do I get from 9 cups of shake to 3 cups of shake? Well, in this case, I just notice that 3 is a third of 9. So essentially, I just happen to notice that 9 divided by 3 equals the 3 cups of shake. So to maintain the proportion, I'm going to say that 2 cups of milk will have to be divided by 3 to get the cups of milk that answer our problem. So 2 divided by 3, in this case 2 cups divided by 3 is 2/3 cups of milk. Does this work for the ice cream? We have 7 parts of ice cream, 9 parts of shake. Again, 9 divided by 3 gives us our 3 cups of shake. So 7 divided by 3 gives us 7/3, or 2 1/3 cups of ice cream. Now the question about this is whether it can be generalized, and so since these numbers, the relationship between 9 and 3 are very easy, a further question of interest would be if we can apply this to 2 cups of milkshake, where we have this relationship. And it's slightly more challenging to consider the relationship of 9 and 2, but it would be a good way to determine whether a student was able to generalize their previous solution if they can correctly navigate this relationship and apply it to solve this problem.